Okay, welcome back to today's class. I do have a couple startups for us to work on here. So if you would like to pause this and just try these, then that would be good practice for you to make sure that you're understanding your angle of depression and angle of elevation that we discussed in the last class. Okay, on this one, we have a 200-foot lighthouse. We have a 30-degree angle of depression. So remember, the angle of depression is from the horizontal looking down. So this would be 32 degrees. I can either translate that 32 down here using my alternate interior angles here, or I can use the fact that this is a right angle and subtract the 32 from 90 and get 68 degrees. Either will be fine with that. So if I translate it down here, then when I set this up, this is my opposite side and I'm trying to find my adjacent side. So the trig function that uses opposite and adjacent is tangent. So this is going to be my opposite and my adjacent. Okay, so once I have this set up, then I'm going to just simply cross multiply. And since tangent of 32 degrees is a number, I'm going to divide that away and I'll get 320.07. So we're going to round that to the nearest whole number and get 320. On the one with the ladder, if we look at the ladder here, the ladder says we have a 20-foot ladder that leans against a building so that the angle between the ground and the ladder is 62 degrees. How high does the ladder reach on the building? So our ladder is 20 feet long, and this angle that they described is an angle of elevation here. So this is going to be 62 degrees. Looking at this, we have the opposite side and we have the hypotenuse. So opposite and hypotenuse is going to be the sine function. So the sine of 62 is x over 20. Once that's set up, cross multiply there and you'll get your answer to be 17.7. Okay, today we're going to be continuing in chapter 6 and we're going to be talking about trigonometric functions of angles. So specifically in chapter 5, we worked with everything in radians. So we're transitioning everything in terms of degrees. And this section 6.3 is going to be a lot of review in terms of the concepts, but it's just kind of taking those concepts and translating it over to degrees instead of radians. Okay, so just kind of as a review, we've already talked about in the first quadrant, excuse me, all of the functions are positive and none of the functions are negative. In the second quadrant, sine and therefore cosecant are your only two positive functions. Everything else is negative. Third quadrant, you've got tangent and therefore cotangent are positive. Everything else is negative. And then in the fourth quadrant, cosine and therefore secant is positive, and everything else is negative there. And we talked also about that the little saying, all students take calculus. So all here students for sine take for tangent, and calculus for cosine. So you can see all the different places as far as remembering which ones are positive and which ones are negative. And like I said, this is review. So it's not like you haven't seen this before. Okay. So just to kind of practice this a little bit more, it's been a little bit since we talked about this. If the sine is less than 0 and tangent's greater than 0, then what quadrant is theta going to be in? So the sine of theta is less than 0 tells us it's going to be down here in the third and fourth quadrants, because those are the two where the y value, remember sine is our y, the y coordinates are negative in these two quadrants here. Tangent is y over x, so in order for it to be a positive, for tangent to be positive, the ratio of these needs to be positive. That tells me that the y and the x need to have the same sign. So if I'm only looking here at already knowing it's going to be either the third or fourth quadrant, it has to be here in the third quadrant, because in the third quadrant, both of these are negative. So if I have a negative divided by a negative, I'll get a positive tangent value. Okay, so here's 4 for you to practice determining the quadrants. Okay, looking at these, sine is negative in the third and fourth quadrants. Cosine is negative in the second and third quadrants. So the third quadrant is one that satisfies both of those. Tangent is negative in the second and fourth quadrants. Sine is negative in the third and fourth quadrants. So the fourth quadrant is one that satisfies both. Secant is positive, the same place as cosine is positive, which is 1 and 4. Tangent's negative, as we just said above, in the second and fourth quadrants. So the fourth quadrant would satisfy both of those. Cosecant is positive, the same places that sine is positive, and sine's going to be positive in the first and second quadrants. Cosine is negative in the second and third quadrants. So the second quadrant is going to satisfy this. Okay, we've talked about reference angles before, but as I said, today we're going to be talking about them in terms of degrees instead of in terms of the radians. So same thing, the reference angle is going to be your first quadrant angle here. We're going to, instead of using the T notation, we're going to use theta. So our reference angle is going to be theta with a bar over it. So theta is always going to be measured from the distance from the x-axis. So in the first quadrant, it's the angle is the reference angle. In the second quadrant, you're going to actually have to take 180 degrees and subtract your angle from it to get your reference angle. In the third quadrant, you're going to take your angle and you're going to subtract 180 degrees in order to get your reference angle, because your angle goes all the way around here. If you subtract 180, then you're left with this reference angle here. In the fourth quadrant, you're going to have to do 360 minus your angle in order to get your reference angle, because you're going to go all the way around into this fourth quadrant. So to summarize that, the first quadrant, you've got your angle is your reference angle. The second quadrant, you're going to do 180 minus that angle. The third quadrant's the angle minus 180. And the fourth quadrant is 360 minus the angle. So just keep in mind your reference angle is always going to have to be between 0 and 90 degrees. So if you start out with an angle that's not between 0 and 360, so it's not on that basic unit circle, then the first thing you're going to have to do is find your coterminal angle that does fall between 0 and 360 before you can apply this to that. So like for instance, if you had 390 is not between here. So the first thing you're going to need to do is to find the coterminal angle that is between here. Okay, and then once you do that, then you can place it into the appropriate quadrants and find your reference angle from that. Okay, so here are some to practice finding your reference angle and determining the quadrant that it's going to be in. So what I would like for you to do is to try these if you're comfortable with it. If not, then just continue to listen and we'll go through it. Okay, this one is in radians, so our reference angle is going to be, as we know, this is going to be pi over 3. And so the actual quadrant, we want to tell what the 5 pi over 3 is going to be in. So looking at your unit circle, we know that 5 pi over 3 is actually going to be in the fourth quadrant. So that it's important to know the reference angle. It's also important to know the quadrant, because the quadrant's going to tell us the sign, positive or negative, and the reference angle is going to help us determine the actual values. Okay, if we look at this next one, 870 is not on the basic unit circle. So what we've got to do is find our coterminal angles, or coterminal angle that is between there. And we'll do that by subtracting 360. So that will be 510. If I subtract 360 again, then I'm going to have 150. Okay, so basically 870 is coterminal with 150. So they fall at the same place on the unit circle. And that place is over here in the second quadrant. So I know I'm working with a second quadrant angle. And as far as my reference angle here, I'm going to do, in the second quadrant, I'm going to do 180 minus the angle. And that's going to give me my reference angle. All right, if we look at this next one here, we've got negative 240. Again, the first thing I've got to do is I've got to get it on that, find a coterminal angle that's on the basic unit circle between 0 and 360. So since this is a negative angle, I'm going to add 360 to that. So negative 240 plus 360 is going to give me 120. Okay, so if I think about my unit circle, 120 is over here in the second quadrant. And as far as my reference angle, I'm going to do 180 minus 120. And that's going to give me 60 degrees for my reference angle. Okay, this one, again, it's not starting out on the basic unit circle, so I'm going to add 360 to that. When I do that, I'm going to get 45 degrees. So 45 degrees we know is in the first quadrant. And we know that in the first quadrant, the angle is its own reference angle. Okay, next we have 170. 170 is actually on the unit circle over here in the second quadrant. So we've got another second quadrant angle. It just so happens that several of these are second quadrant angles. There's nothing special about the second quadrant. So we've got second quadrant, and so in the second quadrant we'll do 180 minus our angle. So we have a 10-degree reference angle. Okay, looking at this one here, this one is actually on the unit circle because it's between 0 and 360. So we know that 270 is down here and 360 is over here. So we're going to be in the fourth quadrant. Okay, and so in the fourth quadrant, we're going to say 360 minus my angle, and that's going to give me a reference angle of 71 degrees. Okay, so hopefully that kind of shows you how to find these reference angles and determine the quadrants that they're in. So I have a few more for you to try, so I would like for you to pause this, try them, and then come back and make sure that you have it. Okay, so for this one, this would be a second quadrant angle, and we would do 180 minus 150, and we would see that we have 30 degrees as our reference angle. This next one, it's not starting out on the unit circle, so what we're going to have to do is we're going to have to go in and add 360 to that until we find an angle that does fit between 0 and 360. So if I add 360 here, I'm going to have negative 270. If I do that again, so I just need to keep adding 360 until I come up with an angle that's between 0 and 360. So 90 degrees is our reference angle. It's its own reference angle. So that is going to be our reference angle. As far as the quadrants, it's between the first and second quadrant there. So here looking at 230, 230 is between 0 and 360. So if we consider which quadrant it's in, 230 is going, this would be 180 degrees. So 180, this will be 270. So it's going to be over here in the third quadrant. So in the third quadrant, we take the angle, which is 230, and subtract 180 from it. So when I do that, I'm going to have a 50-degree angle. So it's in the third quadrant, and it's a 50-degree angle for the reference angle. Here we have one that's negative, so I need to add 360 to it. When I add 360 to that, I get 120. So here we have another second quadrant angle. So we're going to do 180 minus 120, and we'll get 60 degrees as our reference angle. And then we've got for number 11, this one is back to radian, so we're going to have pi over 4 as our reference angle. And as far as the quadrant goes, if I had a positive 3 pi over 4, it would put me over here in the second quadrant. But because it's negative, I'm going to travel that same distance, but I'm going to start here and I'm going to go in the negative direction. So I'm actually down here in the third quadrant. And then finally, 390, we know we want to subtract 360 from that. So we have a 30-degree angle, and that's a first quadrant angle. And in the first quadrant, they are their own reference angles. So our reference angle there is going to be 30 degrees. Okay, so sometimes we want to be able to use this to find different, we want to use reference angles to be able to find different trigonometric functions of angles. So to start out here, we're going to look at this cosine of 135 degrees. So yes, you could put it in your calculator and get the answer. Yes, you could find 135 degrees on your unit circle and find the cosine of that. But I want to specifically show you how to do this using reference angles. So our angle here is 135 degrees. So the reference angle for that is going to be 180 minus 135, which is going to be 45 degrees. Okay, so we know that we could find this by doing the cosine of 45 degrees. So the cosine of our reference angle. And as far as this goes, this is in the second quadrant. So second quadrant over here. So our answers are negative, positive. So that means cosine is negative. So if I take the negative of the cosine of our reference angle, then that's going to give me the correct answer. So negative square root of 2 over. Okay, for part B, we've got the tangent of 390. So we want to rewrite it in terms of a reference angle. So if I do 390 minus 360, we'll get 30 degrees. So we want to rewrite it as tangent of 30 degrees. So we know that 30 degrees is in the first quadrant. So these are actually going to be equal to each other because this is a positive angle that is its own reference angle. So the tangent of 30 degrees, if 30 degrees is the same as pi over 6, so those coordinates are square root of 3 over 2 and 1/2. And if you do sine over cosine, then what you're going to end up with is 1 over the square root of 3, or if you rationalize that, square root of 3 over 3. Okay, if you have some here that are going back to using the radians, you've got the sine of 16 pi over 3, so we're going to divide 16 by 3. We'll go 5 times, so 5 and 1/3, so 5 pi plus pi over 3. So we know that it is a pi over 3 reference angle. So our reference angle is pi over, excuse me, pi over 3. And as far as the quadrant, we've got 1 pi, 2, 3, 4, 5, and then we're going to go a third more. So that's going to put me here in the third quadrant. So I have a third quadrant angle, so I know that the sine value is going to be negative. So this is equal to negative sine of pi over 3. And we know that the sine of pi over 3 is, square root of 3 over 2. So I should have negative square root of 3 over 2 for my answer. Moving on to look at this next one here, negative pi over 4 gives me a reference angle of pi over 4, and negative pi over 4 is in the fourth quadrant. Okay, secant is going to have the same signs as cosine. So in the fourth quadrant, cosine and therefore secant are positive. So this is going to be equal to the secant of positive pi over 4. And that is 1 over the cosine of pi over 4. So we know that the cosine of pi over 4 is the square root of 2 over 2. So if we rationalize this, that just be, or we do keep, change, flip, and then may need to rationalize it. But if we do keep, change, flip, we'll have 2 over the square root of 2. And then if I rationalize that, I'll multiply by the square root of 2 over the square root of 2. and we're going to end up with the square root of 2 for my answer. One thing I wanted to mention is WebAssign will accept your answer like this. I've said this before, but some of you that are going to go on to further maths like calculus, being able to rationalize these is important. So I would suggest continuing to practice with rationalizing these expressions. Okay, so we're going to look at a problem here that is one similar to what we've looked at before. And so I'm actually going to go through it both ways. The first one, I'm going to introduce a new technique using the right triangles. And then I'm also going to show you how we did it back in chapter 5. So if I look at this, I'm going to use right triangles to solve this problem. So I'm going to, first of all, draw my right triangle. Hopefully you can draw yours a little bit nicer than I can draw mine. Okay, we're going to label an angle as theta. And then we're going to use this relationship here to set this triangle up. So if I know that the sine of theta, and don't worry about the positive negative part right now, we're just going to work with the number part. So if I know that the sine of theta is 4/5, that's my opposite and my hypotenuse. Because remember, sine is opposite over hypotenuse. So this allows me to go in and label my triangle. So the side that's opposite theta goes straight across. That's my opposite side. That's going to be 4. And my hypotenuse is always straight across from the right angle. So that's going to be 5. So what I can do now is I can do the Pythagorean theorem on this right triangle. So if this is my x, I'm going to have a squared plus b squared equals c squared. So x squared plus 4 squared equals 5 squared. So this is going to be 16 and 25. So x squared is going to be 9. Take the square root, and x is going to be plus or minus 3. Okay, so we know that the side of a triangle is not going to be negative, so this side is going to be 3. And then now, once we have this triangle, we can actually find all the other trig functions pretty easily. So if we've got sine and we know cosine is adjacent over hypotenuse, we can just look at our triangle and see, okay, here's theta, my adjacent side is 3, and my hypotenuse is 5. So cosine is 3/5. Tangent is opposite over adjacent. So we said my opposite side is 4, my adjacent side is 3. And then once I have these 3, everything else is the reciprocal of it. So the reciprocal of sine is cosecant. So I'll take the reciprocal of this and I'll get 5/4. The reciprocal of cosine is secant. So I'll take the reciprocal of this and I'll get 5/3. The reciprocal of tangent is cotangent. So I'll take the reciprocal of this and I'll get 3/4. Okay, we're almost done. And when I say almost done, we still haven't used the fact that we're in quadrant 4. So in quadrant 4, we have a positive and we have a negative. Okay, so that means that cosine is positive, sine is negative in the 4th quadrant. So our sine they already gave us. So cosine we said was positive. Tangent in the 4th quadrant is negative. Right, cosecant, that's the reciprocal of sine, so it's going to be negative. Secant is the reciprocal of cosine, so it's going to be positive. And cotangent's the reciprocal of tangent, so it's going to be negative. So if you want to go ahead and put your signs in here before you ever do these last 3, that's fine. Or if you want to do all 6 and then go back and put the signs, that's fine. The main thing is don't forget the signs. You have to have them or your answer is not going to be correct. Okay, I wanted to very briefly just show you what you would have to do if this were done the way we did in chapter 5. So in chapter 5, what we would have had to do would be use the sine squared plus cosine squared equals 1. So we substitute for sine. So we get cosine squared theta is 1 minus 16 over 25, which will be 9 over 25. So cosine is, when you take the square root, you get 3/5. And since it's in the fourth quadrant, it's going to be positive. So if we look here, we actually have the same answer here that we got here. It's just a different way of going about it. So the reason that this is called a Pythagorean identity in trig is because it's based off of that a squared plus b squared equals c squared. So we're essentially using the same math. It just looks very different. One is more visual. You set it up in a triangle, use your triangle relationship. The other, you go back to the identity and just grind out the algebra with it. And then from here, once you have sine and cosine, then you'd still go ahead and find tangent, cosecant, secant, and cotangent. All the 6 trig functions. I'm sure I'm not saying them right, but find all the 6 trig functions and go with it from there. Okay, here's another one that I want us to practice with. One reason I like the triangles, aside from it being visual and helping the visual learners, is that you don't have to know all those trig identities because pretty much everybody knows Pythagorean theorem. And if you know the Pythagorean theorem and how to label a triangle, then you can do any of these, even if they don't start us with a sine or cosine. Because see, with this one, you would have to go back to the Pythagorean identity that used tangent squared and secant squared in order to solve it. But if you're going to do it with the triangles, then you can just start with your right triangle here, label your theta. Tangent we know is opposite over adjacent. So my opposite side goes straight across would be 15 and my adjacent side would be 8. So I'll use the Pythagorean theorem to find the missing side over here. So that's going to be, if I use a squared plus b squared equals c squared, a is going to be 8, b will be 15, and I'm trying to solve for my x. So if I combine these together, I'm going to get 289. Take the square root of both sides, and that's going to give me 17. One thing to keep in mind is that the examples we've seen, it's coming out to be a perfect square. That's not always the case. So if this is not a perfect square, then you just need to pull out what you can from underneath the radical, and that's all you can do. Okay, so on my side here is 17, and we want to find the values of the trig functions given this. So if I have it labeled here, I know it's in the third quadrant, so I need to keep that in mind as I do this. Okay, so sine is opposite over hypotenuse. So my opposite side is going to be 15, and my hypotenuse is going to be 17. Cosine is adjacent over hypotenuse, and you can see why it's so important that you know these relationships. At least know sine, cosine, and tangent. Okay, so cosine is adjacent over hypotenuse, so the adjacent would be 8, and the hypotenuse would be 17. We have tangent already given to us. So since we're in the third quadrant here, we know that tangent's negative in the tangent positive in the third quadrant, but sine and cosine are both negative in the third quadrant. Okay, so we get our signs straightened out here. The reciprocal of sine is cosecant. So if I flip this, I'll have negative 17 over 15. The reciprocal of cosine is secant. So that'll be negative 17 over 8. And the reciprocal of tangent is cotangent. So that's going to be 8 over 15. And that completes all the 6 trig functions. Okay, I want to start to talk about trigonometric identities just a little bit. These allow us to rewrite sometimes more complicated expressions in simpler forms and so forth. So in chapter 7, we're going to have a little bit of time to briefly get into trig identities, but I want to just touch on a couple here and then move on. Okay, so you have these basic trig identities that we were speaking of earlier. We know the reciprocal identities. We use those all the time, or you should know those. And then here's our sine squared plus cosine squared. We use that a lot as well. These are not quite as familiar, but they do exist, and they're just derivations of this one here. So the better and the more familiar you are with all these Pythagorean identities, then that's going to help us to be able to do these trigonometric identities a little bit easier. Okay, so here we have one. We're asked to express sine in terms of cosine, and it's in the second quadrant. So we'll worry about the second quadrant part at the end. But here I want to express sine in terms of cosine. So basically that's telling me that I want to solve for sine in terms of cosine. So when I'm solving it in terms of, then the only trig function I want to have left is cosine. So the expression, if we look back here, that actually relates both sine and cosine together is this Pythagorean identity. So that's what I'm going to start with here. I'm going to start with sine squared plus cosine squared equals 1. And I'm going to solve this for sine. Okay, so if I'm solving this for sine, that means the first thing I want to do is to move cosine squared over. Then I want to take the square root of both sides. So sine of theta is plus or minus the square root of 1 minus cosine squared theta. Okay, if we're in the second quadrant, we know that the coordinates are negative, positive. So sine is positive, so that tells me that I'm not going to need this negative here. It's just going to be a positive, and so you can actually not even write the positive, and this would be my answer here in terms of sine. So basically, we want to rewrite tangent so that sine is the only trig function involved. We know that tangent is sine over cosine. Okay, but here we have two different trig functions. The sine one is fine because we're allowed to leave it in terms of sine. Cosine is not. So we've got to replace cosine with an expression that only has sine in it. So what we're going to do is, kind of as a side note here, we're going to go back to our trig function, our trig identity, the Pythagorean identity here, and we are going to solve this for cosine. Okay, so if I solve this for cosine, it's kind of a repeat of what we just did, except this time we're solving for cosine instead of sine. Okay, so cosine is going to be the square root of 1 minus sine squared. This is in the second quadrant, so in the second quadrant it's going to be negative positive. So cosine is actually negative in that second quadrant. Okay, so I'm going to take this expression. So here I know that cosine can be rewritten in terms of sine. I'm going to take this and I'm going to substitute it in here. Okay, so this is now tangent written in terms of sine. Okay, the last thing that I want to look at in this section is finding areas of triangles, and this is when it's not a right triangle, or when the height, which has to be a perpendicular height, is not always easy to find. So basically, we're going to do a rewrite of this, and instead of doing 1/2 base times height, we're going to do 1/2 side A and B times the sine of the theta, which is the included angle between sides A and B. So this is going to be the formula that we're using to calculate area. And again, that's simply because base and height are not always easy to come by in a triangle, but especially if you already just know two sides and the included angle, then this is an easy formula to use. So an example of what I'm talking about here is in this triangle, we have two sides and the included angle between those is provided to us. So our area formula for this is going to be 1/2 the sides times the sine of the included angle. Okay, so on this particular one, our two sides that they're giving us are the 10 and the 3. And then the included angle is the 120 degrees. Okay, if we simplify this, this is going to simplify to be 15 times the sine of 120. If you go back to your unit circle, you're going to see that 120 is in this third quadrant. So our reference angle is 60 degrees, or pi over 3, whichever way you want to think of it. So the coordinates there would be 1/2 and square root of 3 over 2. So I'm looking for the sine, so that's the second coordinate. So I'm going to have 15 and the square root of 3 over 2 as my answer. So if it asks you for an approximation on it and you put this in your calculator, then that's approximately 13 centimeters squared. So I just wanted to show you that simple formula you can use for finding areas of triangles. Sometimes it's more helpful and more useful than the typical one that we normally know. So you can see today a lot of what we did was kind of review, but with a different twist. So hopefully seeing it a second time around, maybe a little bit more of it will be understandable for you. If you have any questions, just let me know and I'll be glad to answer those. And hope to see you at the Zoom sessions, and we'll be finishing up the course very soon. Thank you and have a good day.